Okay, in this video, I'll continue the logistic regression video, and I want to know which of these coefficients are important. So here is one way to do it. There's other ways to go about this. Again, if you were going to do logistic regression for a living, what I'm showing you is limited. There's better techniques, but this stays within what we're doing in the class. And I think even this this video showing you how to step through and looking at different one of these there's value in it. So let's look at this. So the first thing I'm going to do is I'm going to set all these to 0. And that just means I don't know what they are. And what I'm going to do is run the model 4 different times. I'm going to run it when I just have the intercept. I'm just basically saying, just give me the average and not use any of these. And that kind of gives me a baseline. So when I go to Solver, I'm taking these and I'm only going to change this one. That's it. And I hit Solve. And it finds a number. And here's some information. It's kind of a baseline. Here's my likelihood, so I'm going to take this and I'm going to copy it to this yellow and just get the values. And then also over here, take this percent correct and put here, just get the values. I'm going to show that as percent though. So if I just let the intercept, that's the only thing I changed, if I let that occur, then I can get 22 out of how many I had, which is the 61% rate. Don't worry about these yet, because these are going to start becoming important as we move on. Now I'm going to add an additional factor. I'm going to add intercept plus income. I want to see, how does income, so this is like doing a simple linear regression model. How does income influence this probability? So go back to Solver. Now you're going to let it control both of these. And before I do this, remember this: the likelihood's at 24 now. Now I'm going to hit Solve. It's going to change both of this intercept as well as this coefficient. That's only 2. And it says converge to a solution. Look at that. It went from minus 24 and it got bigger by 6. So it moved this likelihood higher, and my percent correct went up. I'm going to copy this, put it here, and I'm going to take my likelihood and I'm going to copy it here. Again, I'm just copying values because I don't want to get the formula. It'll bark at me. So here's things that I've coded up for you. You can look at these probabilities, these p-values. Essentially, what this is, probability is looking at the impact of this model relative to the baseline. So is it statistically different than the base model? That's all it's looking at. It's saying this number, this delta is the difference between the log likelihoods from the base and this one, and this is saying that the probability that they're the same, that they would be the same, is really small. So you can see that that's impactful. The income is incredibly important. Now let's do the other one. Let's go to the next one. Let's now allow it to have two variables. So go under Data Solver. Now change, add age to it, and hit Solve. And originally the likelihood was 18.6, and now it's 18.1, minus 18, which isn't very much. So I'm going to copy that and put right there. I'm going to take this 75 and look at it, it actually went down. The prediction went down. And this is still saying that yes, this model is statistically different than this model, but now I'm going to add something else. I'm going to look at this model compared to this model and see if there's a difference between those two. Again, the likelihood will always get bigger as you add variables. The question is, it took a huge jump there, but it took a very small jump there. So here's the two. If I'm going to calculate this p-value, I'm looking at the difference between this one and this one. Now I'm going to look at the difference between these two. So I'm going to do it down here. I'll do it over there. This is the difference between the one above it, when I had one variable, and now this one. And now I'm going to do a p-value. I'm going to take this chi-dist equal chi-dist of this value, and the degrees of freedom I'm going to leave as still this one. Look at that. The p-value is 0.6, so there is no statistical difference between this model and this one. Essentially saying that age, when you add it, did not add any value. So age doesn't seem to be an important variable. Well, let's just keep going and do the third one. This is how we kind of ended the first video. Let's use all of them. Data solver. I'm going to grab all of these and hit solve. And again, another huge jump. Another huge jump. And my percent correct went up again. So it looks like that if I was going to build a model and make decisions against it, I probably wouldn't use age. I'd probably use income and zip code. I'd probably ignore this one and throw this data out. So that's how you can use this model. You can use this to determine what the drivers are, the important variables are.